What role does the hippocampus play in PTSD and trauma? Trauma can leave a deep mark on the brain, and one of the key players involved is the hippocampus. This small, seahorse-shaped structure is essential for how we process memories, especially those related to our personal experiences. When someone experiences trauma, the hippocampus helps us distinguish between what is safe and what is dangerous by creating detailed memories of those events. But in people with post-traumatic stress disorder, or PTSD, the hippocampus often shows some notable changes. Research shows that in individuals with PTSD, the hippocampus tends to be smaller in size, especially in specific parts like the K1, K2-3, and the dentate gyrus. These areas are important for different aspects of memory and fear regulation. For example, the K1 region is involved in how we re-experience traumatic memories. When this part is damaged or reduced in volume, it can make intrusive memories feel uncontrollable, like flashbacks that keep coming back unexpectedly. This can make it very hard for someone to forget or move past traumatic events. The K2-3 and dentate gyrus regions are linked to how we generalize fear. When these areas are affected, it can lead to overgeneralization of fear responses, meaning that a person might feel afraid even in safe situations. This overgeneralized fear can cause avoidance behaviors and hypervigilance, which are common symptoms of PTSD. Interestingly, these changes in the hippocampus can be worsened if someone also experiences depression alongside PTSD. The hippocampus also plays a crucial role in helping us tell apart safe environments from dangerous ones. When its function is impaired, this discrimination weakens, making it harder to extinguish traumatic memories or feel safe in situations that are actually harmless. This difficulty in distinguishing safety from danger is a core feature of PTSD. Another important point is that a smaller hippocampus might not just be a result of trauma. Some studies suggest that a smaller hippocampal volume could be a pre-existing vulnerability, meaning some individuals might be more likely to develop PTSD after experiencing trauma because their hippocampus is already less resilient. Chronic stress and high levels of stress hormones like cortisol can cause neurons in the hippocampus to shrink and reduce the growth of new neurons, further impairing its ability to function properly. The hippocampus does not work alone. It interacts closely with other brain regions involved in PTSD, such as the amygdala, which processes fear and threat, and the prefrontal cortex, which helps regulate emotional responses. When these regions do not communicate effectively, symptoms like hyperarousal, intrusive memories, and emotional dysregulation can become more severe. Fortunately, some treatments for PTSD, including certain antidepressants and therapies focused on trauma processing, may help promote neurogenesis, the growth of new neurons, in the hippocampus. Restoring hippocampal volume and function can lead to improvements in memory, emotional regulation, and overall symptoms. In summary, the hippocampus plays a vital role in how trauma affects the brain. It helps form and regulate traumatic memories, but when it is damaged or reduced in size, it can contribute to the persistent intrusive memories, overgeneralized fear, and difficulty distinguishing safe from unsafe situations that characterize PTSD. Understanding these changes underscores the importance of approaches that support hippocampal health in recovery. If you or someone you know is dealing with trauma, consulting a healthcare professional is essential for personalized care and effective treatment options.